Hey y'all, today we're going to be learning how to 3D model geometry based primarily on plan sections and some perspective images. In order for you to place your PDFs into Rhino, you're going to have to save them as a JPEG first, and you can do this in Adobe Acrobat. Go up to the menu, click Save As, and then under the drop down, find JPEG and click Save. Now that we're in Rhino, before you do anything, type Document Properties, go to Files, and then make sure you have autosave turned on. Then after that, go to Units, make sure it's feet, and I'm going to use feet and inches as my display type, but this is really personal preference. Tap OK. Also, before you start, make sure down here at the snapping menu that you turn Project on. So what this does is it forces everything you draw to be planar, and it'll be planar on the C plane. And the C plane is this mesh of gray lines, the coordinate axis. So everything you draw will be forced onto that plane. So this will keep everything that we're doing in the same plane so that you don't accidentally draw something deep in or far out of the screen. Now that we're in Rhino, I made a new layer called Picture, and then I'm going to type Picture in the command line, press Enter, select my picture, click Open, and then left click, and then left click again to place. To place my other pictures, all I'm going to do is press Spacebar. That will repeat the last used command in the command line. So it'll open up the file selection tool, and I just click my other plants and sections and drop them in. So now that we have our images in here, we need to make sure that they're scaled to the proper scale so that when we draw in model space, we can use real measurements, and it'll simplify our lives a bunch. Thankfully, all of our PDFs should have come with scales, so we can just use those to scale our images. All you have to do is type scale, and remember that the command line will prompt you on what it wants. So if it asks for a point, all you have to do is click a point to provide the command line a point. So in this case, we're going to use the scale command, and we're going to click the 0 point on our scale. And then we're going to go all the way over here to 60 feet, holding shift to snap to 90 degrees, left click again. And now what we're going to do is we're going to make sure that what we've just delineated, we want to be exactly 60 feet. So we're going to type 60 into the command line, and then we're going to press Enter, and that will scale the line we just drew from 0 to 60 to exactly 60 feet. Now it looks like the drawing didn't really move, so let me use the distance command to measure, and checks out. This drawing should be scaled correctly. So let's just check to see if these measurements in the actual drawing line up. So this little bit that I'm measuring right here is coming out to be more than 6 feet, but when I checked online, I found this image, and the person, who's probably about 6 feet, seems to be as tall as the bottom of the roof. So something's not right in this drawing. So when we take a visual inspection of this scale, we can see that the distance from 0 feet to 30 feet is smaller than the distance from 30 feet to 60 feet, even though they should be the same distance. So we can no longer trust the scale, and we have to use the drawings by themselves to figure out what the size of this building and all the dimensions should be. So Google Maps is a pretty reliable tool if I can't rely on the drawings to determine the size of my building. So I've just Googled my pavilion here and found it on satellite view, and all I have to do is just right click and use the measure distance line, and then just finesse these points. It should tell me what the width of this roof should be. So now if we cross-check the drawings, we can find the width of the roof. Again, holding shift to snap to 90 degrees. And we can scale the width of this roof to be the distance that we found in Google. So now if we check the bottom of the roof to the floor, it is about 6 feet, which seems much more reasonable to the initial photo that we found of the person standing in the building. So now I need to scale the rest of the images to this first image that we just scaled. So one of the ways we can do that is by comparing an element that they all have in common. For example, the width between each of these columns. So I'm going to measure the distance between 4 columns just so that I can divide the inaccuracies between each of the spans. And I end up with just about 16 feet, so I can safely assume that the distances between these columns are 4 feet on center. Now, knowing that the column spaces along the short section are 4 feet apart, I can use the scale command and count out 4 column spaces and scale that to 16 feet. So now these drawings should be at the same scale. Now we can do the same thing with the long section. We'll just measure the distance between 4 spaces and scale the other drawing accordingly. So now that we have everything scaled, we're going to arrange our drawings such that we can work with all of the viewports at the same time to make our 3D modeling process just run a little bit easier. To start, I'm going to take the short section and rotate it such that it lines up better with the plan. Now I'm going to switch into perspective view and rotate the section so that it's kind of standing up from the plan. And I'm going to do the same thing with the long section as well. If when you click on an object you don't get the little gumball thing, just type gumball and turn it on. So now we need to line all of these drawings up so that when we work in this 3D space, we're kind of working on all of these drawings at the same time. So to do this, we're going to choose a reference point. This can be like a column base or something. So looking at this plan drawing, I'm going to pick this column to be my sort of 0, 0 reference point. And I'm going to find that column on every single drawing and sort of line the drawings up such that when I draw something starting from 0, 0, all of the drawings kind of snap there. So on this long section, that column that I picked corresponds to this column right here. So I'm just going to move this drawing and grab it from the base of the column, and I'm going to type 0, 0 into my command line, and that's going to move this drawing exactly to 0, 0. And I'm going to do the same thing with the short section as well. Find the corresponding column, grab the bottom of it, type 0, 0, and enter, and that will move that point that I clicked to 0, 0. Then just do this for the plan as well by grabbing that column that we decided to be our 0, 0 point and moving it to a 0, 0 as well. So now I'm just going to move this plan down a little bit, and when I start working in 3D, I'm going to be kind of working in the center of all 3 of these drawings in perspective. So to check that everything's lining up, I'm going to start a line, and I'm going to type 0, 0 again to set my line starting point. And now we can see in the top view, in the front view, and in the right view that the line is starting at the correct column. And so because of this, we can use these drawings as sort of tracing points and create extrusions from them. So now it's time to decide which part of the building to model. I've renamed a layer to be a sort of temporary demarking layer, and I'm just going to outline which part of the building I'm going to model. So I'm going to model these 2 spans in the short section, and then these 2 spans in the long section. And we can see on the plan where these 2 viewports kind of line up, and we'll draw the rectangle on the plan that corresponds to the area that we're kind of working in. Now we can start 3D modeling. In order to start 3D modeling, we first need to set up our layers. So I'm going to create a layer that's just called 3D, and this will be the layer that kind of hosts every other layer. Then I'm going to create another layer called columns, and I'm just going to drag the column layer into the 3D layer, so it's a sublayer. And I'm going to start from the plan view and work my way up by first creating the columns. So because our drawings are kind of fuzzy and we don't have anything better, we're going to have to rely on measuring the best we can and making educated guesses based on the drawings that we have, as well as the internet with all the images that we can find there. So I'm going to base on these very rough measurements that I'm taking from both the short and long sections. It seems like this column is about 6 inches by 8 inches. Now keep in mind that there are different types of measurements for wood. So you have nominal measurements and you have actual measurements. And typically for standard wood pieces, you can look up a chart and see what size wood would typically be available and make an educated guess based on that. So I'm just going to assume an actual 6 by 8. So I'll start by drawing a 6 inch by 8 inch rectangle on the plan view, and remember to stay in project mode while you're doing this. Now I'm just going to rotate the rectangle so it lines up with the actual building and just center it using the gumball. Now in order to copy this column to the other columns, what I can do is use the gumball, and I can hold Alt while I'm clicking this red arrow, and after I type the number in and press enter, it'll actually copy the shape. And I can do the same thing for the 2 columns below by pressing Alt while I'm clicking the gumball. So now it's time to pull our columns out of the plan. To do this, we're going to select all of our columns by holding Shift and clicking. And then we're going to take a look at other views to see how far we need to pull these columns up. Because our original geometry is curves, we're going to use extrude curve. If our original geometry was a surface, we would use extrude surface. So just be careful between the two of those. Now we're going to take a look at all the settings that we have and make sure that solid is set to yes and delete input is set to yes. Solid in this sense just means that Rhino will create the object such that there are no openings and it is completely solid on the inside, and delete input just means that when we extrude, our original rectangles will get deleted because we don't need them anymore. So from looking at the short section, it seems like these columns actually need to go up different heights, but let's just pull them all up together just to see what we get when we finish the command. So now we have our first 3D shapes, but they look kind of hollow, so let's change that. In the little drop-down menu next to the viewport, click Shaded, and that will make the 3D objects appear solid. Now looking at this perspective view, we can do the same thing, click Shaded, and we can see that we have 3D objects appearing in the center of all 3 of the drawings that we have. Let's undo what we just did and make sure that the heights are created properly. To do this, I'm going to go into the right view and draw a line that marks the top of the columns. We can see that this line isn't really accurate, so I'm going to click it and use the gumball to drag it to where I need it to go. Keep in mind I'm still in project mode in the snap settings. When we go ahead and try to use the actual extrude command, we can see that the snapping of the column is actually centered. So we need to make sure that our guideline intersects with the center of the top of the column rather than one side or the other. If you want to be really verbose, you can set up guidelines and make sure that the intersect snap is turned on, and you will be able to snap your selection right to the intersection of those 2 lines. Now that we have a guideline for the height, we can go back and select these columns and extrude them to their guidelines. We want to make sure that snapping is turned on so they all hit the guideline exactly perfectly. Keep in mind that project is still on. Now we can do the same for the rest of the columns. Now when we look at perspective view, what we just did, we can see our columns are appearing in the very center of all of the images. Now if you want to save the guideline, you could either just hide it temporarily or put it under the same layer as the columns, or if you want to be really explicit about it, you can create a new sublayer under columns and hide the object in there. Next, I'm going to do beams. So I'm going to create a new layer called beams, again under 3D. So now we need to get measurements for the beam, and I'll use a combination of the long and short sections to see if I can get a good number out of this. And now that we're taking a closer look at the short section, we can see that things are kind of not perfectly lined up, but because we're doing approximations here and we don't know what the actual exact values are, making these approximations is okay. Based on my best guess, I think that these beams are 6 inches by 1 foot in section. We can then draw the beams in the right view, and after we draw their outline, we can again use the extrude curve command, and we can look at our long section again, and we can pull this curve using extrude curve all the way across our long section. Now taking a look in 3D, we can kind of see things are starting to come together. But I think I want my beam to extend a little further. And we can take a look at our top view again and see that according to the bounding box that we drew, we might want this beam to run a little bit further than it's drawn currently. So what I can do is go into my perspective view and type extrude surface, because my original geometry now is a surface rather than a curve, because we're using the surface of the already created extrusion to pull out from. So that seems good, and when we click on it, it looks like one solid piece, but there's this little line in the middle that we don't really want, so we can use the command merge all coplanar surfaces, and that will get rid of the line and convert this object into one big long beam. Now, if you realize that you've extruded too far, you can always trim your beams down or objects down. I'm going to do that by creating a plane out of a curve and use the command planar surf to do that. So now I have this big plane that I can use as a big scissor, and I'll use the command trim to trim the excess column away. The issue with the trim command is that it leaves the object open. So if we look in perspective, we can kind of see that this beam is actually hollow now. And if we click properties, we can see that Rhino recognizes this as an open object. So in order to fix that, we're going to cap it. This creates a little piece on the end, and now we can see that that Rhino recognizes the object as closed, which is what we want. Now, if we don't want that behavior of the object being open after we trim it, we can use a different set of commands. The Boolean commands, when used, don't leave objects open. So in this case, we're going to use Boolean split, and we're going to use the plane as a splitting scissor, and it will split this beam in half. We can see that when we execute the command, the beam that's left over is actually closed. So that's one of the advantages of using Booleans instead. A lot of this is personal preference, and depending on the type of work that you're doing, trim might be better than Booleans, and Booleans might be better than trimming. Now that we have our one beam, we can use the copy command to copy it to the other columns, and I'll just use the top left of the column as a reference point and placing the beam on the top left of every single column so that the beam is in the same place for all of these columns. And now that we're looking in perspective, we can kind of see everything is slowly starting to come together.